Question 15, part A says root 2 divided by 8 cubed over 16 to the power of 3 over 2 equals to 2 to the power of n. We have to work out the value of n. So I would advise, like, whenever you see the lowest base, like, base being this thing, this is your base. Let me just highlight it separately. If it's a to the power of n, a is your base, n is your power. So make sure that all of the bases are in the lowest form, which in this case is going to be 2. So we know we can convert 8 into 2 because 8 is equal to 2 cubed and 16 is 2 to the power of 4. So I'm going to rewrite 8 as 2 cubed and 16 as 2 to the power of 4. And root 2 is the same as 2 to the power of 1 over 2. So these are the key changes I'm going to make into this equation. So 2 to the power of 1 over 2 divided by 2 cube whole cube over 2 to the power of 4 whole power 3 over 2 equals to 2 to the power of n. 2 to the power of 1 over 2 divided by 2 to the power of 9 over, whenever we have power inside the bracket and outside the bracket, we multiply the powers. So 4 times 3 over 2 is 6 because 4 times 3 is 12 and 12 divided by 2 is 6. Now, whenever we have similar bases being divided, we subtract the powers. So that's going to be 2 to the power of 9 minus 6, which is 2 to the power of 3. Once again, similar bases being divided, we subtract the powers. So 1 over 2 minus 3 equals to 2 to the power of n. And 1 over 2 minus 3 is negative 5 over 2. So same bases on both sides, we put the powers equal to each other. So we can write it as negative 2.5. That's your answer. Then it says find 4% of 4.5 times 10 to the power of 157, giving your answer in standard form. So 4% of 4.5 times 10 to the power of 157. I'm going to rewrite 100 as 10 square. And just like we did in the previous part, when similar bases are being divided, we subtract the powers. So it's going to be 4 times 4.5 times 10 to the power of 157 minus 2. Now 4 times 4.5 is 18, and this is 10 to the power of 155. If you're wondering if this is in standard form or not, it's not. So the 18 is rewritten as 1.8. Why? Because every whole number has a decimal at its end. So this decimal is moved over here. So if 18 is becoming 1.8, that means we're going to add 1 to the power over here as well. Because 18 times 10 to the power of 155 is the same thing as 1.8 times 10 to the power of 156. The only difference is that in the second thing, we have a decimal after 1, whereas there is no decimal in the first one. So this is your standard form. In standard form, there's a decimal after the first digit, and the first digit has to be greater than 0. Question 16 says the Venn diagram shows a universal set and sets A, B, and C. The numbers on the letter X represent numbers of elements. Given that the number of A union B is 42. When it's a U, it's union. When it's an upside down U, it's intersection. So A union B means all the elements. A union B means all of these elements. So that's going to be 9 plus 5 plus 3 plus X plus 7 plus 12, and that equals to 42. Let's collect the like terms again. So that's going to be 36 plus X equals to 42. X is going to be 42 minus 36, which equals to 6. So X is 6. Then it says find the number of A complement. A complement means the terms that are not a part of A. So terms that are not a part of A are these ones. So that's 10 plus 7 plus 12 and this 7 as well, because this is also A complement. It's not a part of A. So we'll do 10 plus 7 plus 7 plus 12, which is 36. That's the number of A complement elements. And then find the number of B complement intersection C. B complement intersection C is going to be anything that's not a part of B, but is a part of C. So anything that's not a part of B is a part of C is this, 5 and 10. 5 is a part of C, 10 is a part of C. So 5 plus 10, and that is 15. That's your answer. Next question says that the function g and h are such that g of x is 11 over 2x minus 5 and h of x is x squared plus 4, where x is greater than equal to 0. What value of x must be excluded from any domain of g? So when you have a rational function, which is when your function is in a fraction and the variable is in the denominator, you put the denominator equal to 0 and find the value of x, which is 5 over 2. Now, this is the value of x where the domain does not exist. Why? Because if we substitute, now this is the value of x where the function does not exist. Why? Because if we substitute 5 over 2 in the function, we can see that we get 11 over 5 minus 5, which is 11 over 0, and that's undefined. Whenever we divide anything by 0, that thing is going to be undefined. Hence, x equals to 5 over 2 is the value at which the function does not exist, because it's undefined there. Let's say solve g of hx equals to 1. So that means we're going to substitute hx into g. Whatever function is written second, that is substituted in the first function. So g of hx is 11 over 2 bracket x squared plus 4 bracket close minus 5. As you can see, we just replace the x with h of x because h of x is now the new domain of g of x. So 1 equals to 12. So 1 equals to 11 over 2x squared plus 8 minus 5. So that's 2x squared plus 3 cross multiply. 2x squared plus 3 equals to 11. 2x squared equals to 11 minus 3, which is 8. 8 divided by 2, that's 4. Square root on both sides, x is going to be plus minus 2, but we will only take x equals to positive 2. Why? Because h of x exists only for positive value of x, not negative. Question 19 says OMA, ONB, MPB, and NPA are straight lines. M is the midpoint of OA. ON is to NB is 1 is to 5. OM equals to A and ON equals to B. Find in terms of A and B the vector AN. So if OM is the midpoint of OA, OA is going to be twice of OM, which is 2A. So AN is going to be ON minus OA, which is B minus 2A. That's your vector AN. Then it says use a vector method to find the ratio AP is to PN. So for APs to PN, we can see that P lies on the line MB and P lies on the line AN. So basically, I'm going to use these two lines to create equations for OP. Then I will put the OP equations to each other to figure out our ratio as well. So first, I'm going to begin with saying AP is to PN is what we're trying to find. ON is equal to B. NB is going to be 5B. Why? Because ON is to NB is the ratio 1:5. So if ON is B, NB is going to be 5B, and OB is going to be B plus 5B, which is 6B. So OB is B plus 5B, which is 6B. So we can find MB, which is OB minus OM. OB is 6B and OM is given the question as A. So 6B minus A is MB. If we go back to the diagram, we can say that AP, which lies on AN, so AB is a multiple times AN. Okay. So AP equals to a multiple, which is lambda times AN. And AN is what we already found to be B minus 2A. So AP equals to lambda times A lambda times B minus 2A. We can split AP into OP minus OA, which equals to lambda times B minus 2A. So OP is going to be lambda times B minus 2A plus OA. OA is given as 2A. So if we expand this, lambda B minus 2 lambda A plus 2A. So I'm going to collect the A's. So lambda B plus A bracket 2 minus 2 lambda. This is OP. Now this is the equation of OP using the line AN. Now I'm going to create another equation for OP using the line MB. So I'm going to use a different color for that. Once again, MP, which lies on the line MB, is a multiple that is mu times MB. MP equals to mu times 6B minus A because that's what MB is. MP can be split into OP minus OM. Equals to mu times 6B minus A. So OP equals to mu times 6B minus A plus OM, which is going to be mu times 6B minus A plus A. This is our second equation for OP. Now I'm going to put these two equal to each other to find the value of mu and lambda. Lambda B plus A bracket 2 minus 2 lambda equals to A minus mu A plus 6 mu B. So the B is equal to each other and the A is equal to each other. So for A, it's going to be 2 minus 2 lambda equals to 1 minus mu. And for B, it's going to be lambda equals to 6 mu. So if lambda equals to 6 mu, we can substitute that in the equation. So let's highlight this. That's going to be 2 minus 2 times 6 mu equals to 1 minus mu. 2 minus 12 mu equals to 1 minus mu. 2 minus 1 equals to 12 mu minus mu. That's 1 equals to 11 mu. And 1 over 11 equals to mu. If 1 over 11 equals to mu, lambda is going to be 6 over 11. So the question was asking us to find the ratio of AP is to PN. AP is to PN. Now AP was lambda times AN. So that's going to be 6 over 11 times AN. And if AP is 6 over 11 times AN, that means PN, which is also a part of AN, that's going to be 5 over 11 times AN. Because if the total line is A to N and then there's P over here, AP is 6 over 11, so this is 5 over 11. So going back to this, that's going to be 6 over 11 ratio 5 over 11, which simplifies to 6 over 5. That is your ratio of AP is to PN. Question 20 says the sum of the first 80 terms of an arithmetic series is 470. The 75th term of S is 14.5. The sum of the first X terms of S is 171. Work out the value of X. So sum of the first 80 terms is 470. Your 75th term is equal to 14.5. And sum of the first X terms is 171. 171. 171. So using the 75 terms 14.5, we can say that 14.5 equals to the first term, which is A, plus 75 minus 1 times D. I'm using the nth term formula over here to create an equation in terms of the first term and the common difference. So that's 14.5 equals to A plus 74D. This is our first equation. Then it told us that the sum of first 80 terms is 470. So 470 equals to 80 over 2. I'm using the sum formula to create an equation in terms of A and D again. So n over 2 times 2A plus 80 minus 1 times D. So that's 470 equals to 40 times 2A plus 79D. Which becomes 11.75 equals to 2A plus 79D. This is our second equation. Okay. Now that we have two equations in terms of A and D, we can solve these simultaneously to find what A and D are. So let's do that over here. I'm going to use elimination method to find the values of A and D. And for that, I'm going to times the first equation by 2. So 2 times 14.5 equals to A plus 74D, which is going to give us 29 equals to 2A plus 148D. I'm going to solve this with equation number 2. So 11.75 equals to 2A plus 79D. Since A is positive in both the equations, so to get rid of A, we need to subtract both the equations. So it's going to be 29 minus 11.75, which is going to give us 17.25. 2A minus A is 0. And 148 minus 79D is going to be 69D. 17.25 will be divided by 69 to find the value of D, which is going to be 0.25. That's what your common difference is for this arithmetic series. Now, let's find the value of A. So we'll put the difference value in either of the equations to find what A is. I'm going to use the first equation. 14.5 equals to A plus 74 times 0.25. So 14.5 equals to A plus 18.5. 14.5 minus 18.5 equals to A, which is going to be negative 4 equals to A. So that's the value of A. Now we're going to use this to find what X is, because in this, the unknown terms were the first value, the common difference, and the number of values. So we have the common difference, we have the first term, so the only number that is unknown now is the number of values, which is X. So let's find that. Sx equals to x over 2 times 2 times negative 4 plus x minus 1 times 0.25. So Sx is 171. So 171 equals to x over 2 times negative 8 plus 0.25x minus 0.25. Cross multiply, so 171 gets multiplied by 2, and that's x equals to negative 8.25 plus 0.25x. So 171 times 2 is going to be 342 equals to x gets multiplied with both the terms inside the bracket. So that's negative 8.25x plus 0.25x squared. Bring all the terms on one side. So 0.25x squared minus 8.25x minus 342. I'm going to multiply the entire equation by 4 to get the decimal. So this getting multiplied by 4. So that's going to be 0 equals to x squared minus 33x minus 1368. Now we factorize this. So that's going to be x squared plus 24x minus 57x minus 1368. Factor by grouping, we have x common in the first two terms, so x plus 24 comes in the bracket. Negative 57 is common in the third and the fourth term, so we have x plus 24 in the bracket again. Between x and negative 57, we have x plus 24 common, so we're left with x minus 57 in the bracket. So one value of x is negative 24 and the other is 57. Obviously, the number of terms cannot be negative. So the x value that we're choosing is 57. So that is your answer. Question 22 says diagram shows two circles with center O and a regular pentagon A, B, C, D, E. A, B, C, D, and E are points on the larger circle. The pentagon has sides of length 8 centimeters. The diagram is shaded such that shaded area equals to unshaded area. Work out the radius of the smaller circle, giving your answer correct with 3 significant figures. So since it's a regular pentagon, we have already discussed that in regular pentagons, the sides are the same. So if the sides are the same, angles at the center is also the same. So if I divide, so if I draw a line from the center towards each vertex of the pentagon, we're dividing the shape into 5 equal triangles. And all of these triangles will have the same angle. So to find that angle, we will do 360 divided by 5, which gives us 72 degrees, which means all of these angles are 72 degrees. So now if the angles are the same and the lengths on the boundary of the pentagon, they're also the same, which means we have 5 identical triangles. They want us to find the radius of the smaller circle. So first, let's begin with finding the radius of the larger circle, which is OA, OB, OE, OD, OC. All of these represent the radius of the larger circle. So we know this is 8. These are r, so we can use the cosine rule to find the value of r, because for the cosine rule, we need two lengths and the angle between them. So we already have the answer over here. We're trying to find those two lengths. And luckily, those two lengths are the same thing. So we'll just have one unknown. 8 square equals to r square plus r square minus 2r square cos of 72. So that's going to give us 64 equals to 2r square minus 0.618 r square. 64 equals to 1.382 r square. 64 divided by 1.382 equals to r square, which is going to be 46.309. Take the square root of that to find the value of r, and that's going to be 6.805 centimeters. That's the radius of the larger circle. Now, since we have the radius of the larger circle, we can find the area of the larger circle. So area of larger circle, that's going to be pi times 6.805 square, which is going to equal to 145.48 centimeters square. To find the area of the pentagon, we can find the area of one triangle and then times it by 5. So area of pentagon would be 5 times the area of the triangle, which is 1/2, times r squared, which is 6.805 squared, times sine of 72. We're using the formula that we use for non-right angle triangles. So that's 1/2 AB sine of angle C. Over here, A times B is the radius. So R times R. That's why it's 6.805 squared. And angle is 72. For us to be able to apply this formula, the conditions are the same as the cosine rule. We need two lengths and the angle between them. And we did have that. So for the area of the pentagon, we're going to have 110.10 centimeters square. So now to find the shaded area outside shaded area, I'm going to find the difference of these two. So 145.48 minus 110.10, and that is going to give me 35.38 centimeters square. This is basically this area. This is the area that I just found. This is it. Now, they told us that the shaded area is the same as the unshaded area. So if they're the same, shaded area is basically this one plus area of the circle inside the pentagon. And unshaded area is the pentagon minus the area of the circle. So what I'm going to do is shaded equals to unshaded. So that's 35.38 plus pi r squared, which is area of the small circle, equals to 110.10 minus pi r squared. For the unshaded area, we're subtracting the area of the smaller circle. And for the shaded area, we're adding the area of the smaller circle to this outside blue area. So collect the like terms on each side. Pi r squared plus pi r squared equals to 110.10 minus 35.38. So that's 2 pi r squared equals to 74.72. R squared equals to 74.72 divided by 2 pi. And then we square root both sides. And the radius is coming out to be 3.45 centimeters. That is your final answer. Correct to 3 significant figures. Question 23 says the frustum is made by removing a small square-based pyramid from a similar large square-based pyramid as shown in the diagram. The height of the small pyramid is 15 centimeters. The height of the large pyramid is 45 centimeters. The square base of the large pyramid has side length 39 centimeters. Work out the total surface area of the frustum, giving your answer correct to the nearest whole number. First, I'm going to begin with figuring out the scale factor by which the shape is enlarging. Scale factor is going to be 45 divided by 15 because they're both similar pyramids. So that means the scale factor is going to be the new height divided by the old height, which is 3. So that means if the base is 39 centimeters for the large pyramid, for the small pyramid, the base is going to be 39 divided by 3, which is 30. So this is 13 by 30. So now that we've covered the base, so area of square bases are going to be 13 square plus 39 square, which is 1690 centimeter square. Now, moving on to the side parts. So we have triangles on the side. So for that, we need this height. And to find this height, I am going to make a right angle triangle over here. And the same goes over here. So since this is right in the middle of the pyramid, so this is going to be 39 divided by 2, and this is going to be 13 divided by 2. For the bases of these right angle triangles. The height for this is 15, and for that one is 45. So we can use Pythagoras to find the hypotenuse for these two right angle triangles. So for the first one, I'm going to call this x1. I'm going to call this x1, and I'm going to call this entire one as x2. So x1 is going to be square root of 15 square plus 6.5 square. 13 divided by 2 is 6.5. So that is going to give me 16.34 centimeter. x2, which is the hypotenuse of the larger right angle triangle, that's going to be 45 square plus 13 divided by 2 square, which is 19.5 square. That is going to give me the value of 49.04 centimeters. Okay, now that we have the hypotenuse of both the right angle triangles, we can easily find the area of these right angle. We can easily find the area of the triangle faces for both the small and the large pyramid. So for small pyramid, area of 4 triangles is going to be 4 times 1 over 2 times the base, which is 13, and height, which is 16.34. That gives us 424.84 centimeters square. Then area. Then for the large pyramid, area of 4 triangles is going to be 4 times 1 over 2 times 39 times 49.04. That's going to give me 3,825.12 centimeters square. So total surface area is going to be the difference of the triangular faces plus area of square bases. So Frustum area is 3,825.12 minus 424.84 plus 1,690. And that gives us 5,090.28. They want the answer correct to the nearest whole number, so that's 5,090 centimeters square. That is the total surface area of the frustum. Question 22 says the diagram shows a triangle ABC in a flat pole BF. AB and C are points on horizontal ground. BF is vertical. AB is 9 meters, BC is 11 meters, AC is 16 meters, and BF is 10 meters. D is the point on AC such that angle BDC is 90 degrees. Work out the size of the angle of elevation of the point F from the point D, giving your answer correct to one decimal place. So let's first convert. So let's first connect B and D and then with F. So this is point D. And since BDC make a 90-degree angle, this is a 90 and so is this. So now we can see that we have two right angle triangles in this non-right angle triangle, which is ABC. And in the triangle ABC, we have all three lengths. So first, I'm going to begin with finding angle C. So to find angle C, I'm going to use the cosine rule because we have all three lengths of this triangle. I need to find the angle. So cos of angle C is going to be 11 square plus 16 square minus 9 square divided by 2 times 11 times 16. So that's going to give us 0.840909. Then we take cos inverse of this. And that will give us 32.76 degrees. So that's angle C. So once we have angle C, we can use that to find the length of BD because it's a right angle triangle. This is B, this is D, this is C, this is 11, this is 32.76. So we have the angle, we have the hypotenuse. What we're trying to find is the opposite. So we'll use sine of 32.76 equals to BD over 11. So 11 times sine of 32.76 equals to BD. So that is going to give us 5.95 meters as the length of BD. Now, the question was asking us to find this angle over here, the angle that BF makes with BD. So we have the length of BF, which is given as 10. We have the length of BD, which is given as 5.95. So to find this angle, we'll use tan. Tan theta equals to opposite, which is 10, divided by the adjacent, which is 5.95. So theta is going to be tan inverse of 10 divided by 5.95. And that's going to give us 59.2 degrees. That is the angle correct to one decimal place. Question 23 says diagram shows a cuboid with a square cross section. The volume of the cuboid is 13 plus 6 root 5 centimeter cube. Without using a calculator, find the value of x. Give your answer in the form of a plus root b, where a and b are integers. Show working clearly. As you know, volume is the cross-section area times the length of the object. So cross-section is a square. So this is, if we highlight this over here, this is your cross-section area. So that's x times x. So volume is basically 13 plus 6 root 5. 13 plus 6 root 5 equals to x squared times 2 root 5 minus 3. Times 2 root 5 minus 3. So it's going to be 13 plus 6 root 5 divided by 2 root 5 minus 3, which equals to x squared. So now to find the value of x, we're going to rationalize the denominator. When you're rationalizing the denominator, basically what we're doing is we're trying to get rid of the surd from the denominator. So to do that, I'm going to multiply the fraction by the conjugate of the denominator, which is 2 root 5 plus 3. So both the numerator and the denominator are going to get multiplied by 2 root 5 plus 3. It's the same as when we're, adding or subtracting fractions with unlike denominators. We multiply both the numerator and denominator by the number. Same thing over here, we multiply the numerator and denominator by 2 root 5 plus 3. So now when we multiply them, we get 13 plus 6 root 5 times 2 root 5 plus 3 divided by 2 root 5 minus 3 times 2 root 5 plus 3 equals to x squared. Expand the brackets in the numerator and the denominator. For the numerator, it's going to be 13 times 2 root 5 plus 13 times 3, then 6 root 5 times root 5 plus 3 times 6 root 5 divided by, now in the denominator, if you notice, it's 2 root 5 minus 3 times 2 root 5 plus 3, which reminds us of a minus b times a plus b, which equals to a square minus b square, difference of perfect squares. Always remember when you're rationalizing the surd and the surd is in the denominator, you will apply difference of perfect squares. So based on difference of perfect squares, 2 root 5 minus 3 times 2 root 5 plus 3 will turn into 2 root 5 whole square minus 3 whole square equals to x squared. 13 times 2 is going to be 26 root 5. 13 times 3 is 39. 6 root 5 times 2 root 5 is going to be 12 times 5, which is 60. And 3 times 6 root 5 is 18 root 5. Remember, when you're multiplying a number by a surd, the 3 will only get multiplied by 6, not by 5. So the 5 will remain as it is inside the root. Whereas when we did 6 root 5 times 2 root 5, we did 6 times 2, which is 12. And then root 5 times root 5 is root 5 squared, which is the same as 5. Hence, 12 times 5 gave us 60. And the denominator, 2 root 5 squared becomes 4 times 5 minus 3. So that's 26 root 5 plus 18 root 5 is going to give us 44 root 5. 39 plus 60 is 99 divided by 20 minus 9, which is 11. So this is equal to x squared. So this is equal to x squared. So that's going to be 44 root 5 plus 99 over 11 equals to x squared, which is 4 root 5 plus 9. In the question, it said that we have to express x as a plus root b. So since we cannot take the square root of, 4 root 5 plus 9, what we can do is we can rewrite x as a plus root b whole square. So now what we can do is we can expand the bracket on the left-hand side, and then we can compare the similar terms on each side to figure out what a and b are going to be. So a plus root b whole square is going to be a square plus 2a root b plus b equals to 4 root 5 plus 9. Now we know a square plus b is equal to 9 because they're the only constants. And the surds are 2a root b equals to 4 root 5. Now, since there's only one surd and 5 is a prime number, so b is going to be 5. And if you put the 2a equal to 4, a is equal to 2. And in order to check if we're correct or not, we can put back a over here. So 2 square plus 5 is the same as 9, which means x is 2 plus root 5. This is how you can figure out what x is going to be in case you calculate the value of x squared. So remember, you cannot take the square root of like a square root. It's going to be very, like, obviously you can, but like at this level, you're not taught how to do that. So it's going to be very time consuming if you just like, square root it and try to figure out what the answer would be. So it's best to just replace the x with the form that they've given the question. They said that x needs to be the form of a plus root b. So rewrite x as a plus root b, square that, expand the bracket, compare the like terms on each side. A square and b are the constants, 9 is the constant, so we put that together. And then 2a root b and 4 root 5 are the surds, so we put that together. And from that, we figure out what a and b are. So that gives us the value of x. Question 24 says ABCD is a kite with AB equals to AD and CB equals to CD. A is the point with coordinates negative 2, 10. B is the point with coordinates negative 3, 7, 0, 5, 4. And C is the point with coordinates 4, negative 5. Work out the coordinates of D. So let's draw the kite. A, B, C, D. AB is equal to AD, BC equal to CD. So we know that the gradient of, so if you're familiar with the shape of a kite, the diagonals in a kite meet at a 90 degree. So they're basically perpendicular to each other. So if we begin with finding the gradient of AC, we can use that to find the gradient of PD as well. So gradient of AC is going to be negative 5 minus 10 over 4 minus negative 2. That gives us negative 15 over 6, which simplifies to negative 5 over 2. If you remember, when two lines are perpendicular, the gradient of one line times the gradient of the other line is equal to negative 1. That is the condition for perpendicular lines. Based on that, gradient of BD would be 2 over 5. Why? Because if we do negative 5 over 2 times M2 equals to negative 1, M2 would be negative 1 times 2 over negative 5, which is equal to 2 over 5. So that's the gradient of BD. Now, if we create an equation for the gradient of BD, that's going to be 2 over 5 equals to 4 minus y over negative 5.4 minus x. Because the formula for the gradient is y2 minus y1 over x2 minus x1. So y2 and x2 are point B and x1 and y1 are point D. So we just substitute the values. Now we're going to cross multiply. It's going to be 2 times negative 5.4 minus x equals to 5 times 4 minus y. So that's negative 10.8 minus 2x equals to 20 minus 5y. 5y comes to the other side, so 5y minus 2x equals to 20 plus 10.8. So that's 5y minus 2x equals to 30.8. This can be rewritten as 5y equals to 2x plus 30.8. divide everything by 5, and y equals to 0.4x plus 6.16. That's your equation. Now, they have already told us that AB equals to AD and BC equals to CD. So we can use these lengths to figure out what the coordinates of D are going to be. So we know that the distance of AB is the same as distance of AD. So magnitude of AB is the same as magnitude of AD. So magnitude of AB is going to be square root of 10 minus 4 square plus minus 2 plus 5.4 square. That gives us square root of 36 plus 11.56. And that's going to be 6.896. Then magnitude of AD is going to be square root of 10 minus y square plus negative 2 minus x whole square. So basically, since AB is equal to AD, so we put this equal to each other. 6.896 equals to square root of 10 minus y whole square plus negative 2 minus x whole square. Now, if you remember the equation that we created previously, which was y equals to 0.4x plus 6.16. So what I can do is I can replace the y in this equation with x, and then we will only have one unknown, which is x. So first, let's get rid of the square root over here by squaring both sides. So that's going to give us 47.56 equals to 10 minus 0.46 minus 6.16 squared plus 2 minus x whole square. Let's expand the bracket now. So 47.56 equals to 3.84 minus 0.4 x whole square. And then plus negative 2 minus x whole square. So 47.56 equals to 14.745 minus 3.072x plus 0.16x squared plus 4 plus 4x and then plus x squared. Let's bring everything on one side and combine the like terms. So that's going to be 1.16x squared plus 0.928x minus 28.815. Now you'll factorize this quadratic equation using the quadratic formula. So x equals to negative 0.928 plus minus square root of 0.928 squared minus 4 times 1.16 times negative 28.815 divided by 2 times 1.16. That's going to be negative 0.928 plus minus 11.6 over 2.32. One value of x is going to be 4.6 and the other value of x is going to be negative 5.4. We're going to select 4.6 because D is going to be on the right-hand side of B. And B was already negative, so right-hand side would be a positive number. So x equals to 4.6. So we put this in this equation. So y would be 0.4 times 4.6 plus 6.16. And that gives us the y value of 8. which means when x is 4.6, y is 8. These are the coordinates of point D. Then question 25 says a solid sphere has a radius of 2.8 centimeters correct to one decimal place. The sphere has a mass of m pi grams, where m is 260 correct to two significant figures. Work out the upper bound for the density of the sphere, giving your answer in grams per centimeter cube correct to two decimal places. Show your working clearly. So firstly, density is mass over volume. If they want the upper bound of mass, that means mass will be upper bound and volume will be lower bound. Because in division, if you're trying to find the upper bound, the numerator is the upper bound and denominator is the lower bound. So now to find the lower bound of volume, we need to find the lower bound of the radius. So radius is 2.8 centimeters correct to one decimal place. So lower bound of radius would be first we divide the degree of accuracy, which is 0.1 by 2, which gives us 0.05. So lower bound of radius would be 2.8 minus 0.05, which is 2.75 centimeters. Now we find the lower bound of volume using this radius. So volume would be 4 over 3 pi r cubed. R would be 2.75. So the volume comes out to be 87.114 centimeter cube. Now mass was m pi, where m is 260 correct to two significant figures. So in 260, the second significant figure is 6, and the place value of 6 is 10. So for upper bound of mass, when trying to find the upper bound or the lower bound, when the value is correct to significant figures, you first begin with seeing what it's correct to. This is correct to two significant figures. Now we need to check what is the second significant figure in the number. Second significant figure is 6. Next step is to see what is the place value of 6. Place value of 6 is 10. So we divide the place value by 2, which gives us 5. So degree of accuracy was 10. 10 divided by 2 is 5. So for upper bound of mass, we do 260 plus 5, which is 265 grams. So density is going to be 265 pi, because mass is m pi, divided by 87.114, and that is going to give us the value of 9.56 gram per centimeter cube. That is the upper bound for density.